Hello students, in this video we'll see an example of using the central limit theorem to compute an approximate probability. Let's suppose that a class of 30 students takes an exam, and each student's score is an independent of other students and has common distribution with mean 70 and standard deviation of 10. Let's compute the probability that the average score is more than 82. So to do this, what we'll note is that the average score in the class, so the average score, will be equal to the first score plus the 30th score, all divided by 30. So what we want is to find the probability that S1 plus S30 over 100 is bigger than 82. What we'll try to do is apply the central limit theorem, which, if we recall, states that if you have x1 through xn iid, then x1 plus xn minus n times mu, the common mean, over square root of n times sigma approaches a normal distribution, a normal 0-1 distribution. That's our central limit theorem. So what we need to do is we need to put this problem into this form. So what we can do is we can first multiply by 100 and find that our probability is equivalent to the probability that S1 plus S2 plus S30 is bigger than 8,200. And then what we'll do is we'll subtract off n times the mean. So we have 30 students, that's our n, and the mean is 70. So we'll subtract that off. So this is the probability that S1 plus S30 is bigger than or equal to minus 30 times 70 is bigger than 82. Oh, this should be a 30 over here because it's the average, so we have 30 students. So that will be a 30 over here. And this will turn into a 82 times 30. 82 times 30. And then times 30 over here, minus 70 times 30. And so what this becomes is this is going to be a 12 times 30. 12 times 30. And that will be 360. So we have the probability that S1 plus S30 minus 2,100 is bigger than 360. And now we'll divide by the square root of n, so that's the square root of 30, times the standard deviation of 10. So we'll divide by that, square root 30 times 10. And so what we'll get over here is we'll get the probability that S1 plus S30 minus 2100 over root 30 times 10 is bigger than, well, this is going to be a 36 over square root 30. And now this is approximately normal, and so this will be equal to approximately 1 minus the cumulative distribution of a normal 0, 1 random variable, 36 over the square root of 30. And this is a very, very small number, so this is very, very likely that this will not happen. Thank you very much.